In this section, we're solving systems of equations using a new method called elimination. We're going to try to eliminate a variable using addition, subtraction, and sometimes multiplication. There are also times we'll have to arrange systems so we can solve by elimination. By which method can we already solve a system? We can already solve a system using the graphing method. This is where we graph two lines and identify the point of intersection. So now we're going to find a new way or learn a new way to solve a system that involves eliminating a variable. And so if I look at example 1, when I eliminate a variable, my goal is to either add my equations together or subtract them from each other in order to get a variable to go away. And so what I notice here is that 2x and negative 2x are opposites, which means that if I were to add these equations together, my x variables would disappear. Now I'm going to draw a circle here, and inside this circle I'm going to put a plus sign as a reminder to myself that I'm adding these equations. The other thing to keep in mind is that everything is nicely stacked upon each other. X's on top of x's, y's on top of y's, and equal signs on top of equal signs. This is important to make sure that you're able to eliminate one of your variables. 2x plus negative 2x would be 0, so my x variable would be gone. 3y plus 5y would be 8y. Bring down my equal sign just like I do when I'm solving an equation, and 11 plus 13 would be 24. Then to get y by itself, I would divide both sides by 8, and this would mean that my y variable would be 3. But remember, when we're solving a system, we're really looking for the point of intersection, and a point is made up of two coordinates, an x and a y. Right now, I only have my y coordinate. So to find the missing x coordinate, I could put y equaling 3 in either of these two equations. I'm going to go ahead and put it in the top. So I'm going to have 2 times x plus 3 times y, but y is 3, equals 11. Now I'm solving a traditional single variable equation. 2x plus 3 times 3 is 9, equals 11. I could subtract 9 from both sides, which means 2x would equal 2. And then if I divide both sides by 2, I'm going to get x equals 1. And so now I can plug that into my ordered pair, and so here's my solution to this system of equations, 1, 3, which means that if I were to graph these two lines on Desmos, I would expect that they would intersect at the point 1, 3. On example 2, I noticed that I have 3y and 3y, which means that I could actually subtract these equations from each other in order to cause them to eliminate. So I would draw my line, I would put my circle, and inside that circle I would put a subtraction sign to show myself that that's what I'm doing. 4x minus 5x would be negative 1x. 3y minus 3y would cancel. My equal sign would come straight down. Here's where you have to be careful. 2 minus negative 2 would really be positive 4, because subtracting a negative really means adding a positive. Then I could divide both sides by negative 1, and this would mean that the x part of my coordinate would be negative 4. I still need to find the y half. I could put negative 4 into either of my two equations. I'm going to go ahead and put it in this top one. So I'm going to do 4 times negative 4 plus 3y equals 2. 4 times negative 4 is negative 16. To move negative 16 to the other side, I would add it, which would get me 3y would equal 18, and then I would divide both sides by 3, which means my y coordinate would be 6. And so my solution to the system is negative 4, 6, which means if I were to graph these two lines on a coordinate plane, I would expect them to intersect at the point negative 4, 6. Now some people don't like subtracting, and so what they might do is they might keep the top equation 4x plus 3y equals 2, and then they might multiply this entire bottom equation by negative 1 just to make the 3y its opposite. And so this would create the new equation negative 5x minus 3y equals positive 2. It's just important, if you're going to do this, to make sure that you multiply every single part of your equation by that same number. And then because it's a positive 3y and a negative 3y, I could add these two equations instead of subtract them from each other. Pause the video, try examples 3 and 4, press play when you're ready to check your answers. On example 3, since I have positive 3x and negative 3x, I'm ready to add these equations together. 4y plus 5y is 9y, 8 plus 10 is 18, and then divide both sides by 9 to get a y coordinate of 2. We still need to find our missing x coordinate, so I can put it into the top equation. Either one is fine. 3x plus 4 times 2 is 8, and then to get rid of 8, we subtract it from both sides. 3x equals 0, and divide both sides by 3 for an x coordinate of 0 for a solution of the point 0, 2. On example 4, since I have a positive 6y and a positive 6y, I could either subtract these two equations, or I could make this equation its entire opposite in order to be able to add them. I went with subtraction, but either way is fine. 5x minus 7x is negative 2x, 6y minus 6y is 0, and 4 minus 8 is negative 4. Divide both sides by negative 2 to get an x coordinate of 2. I then took x equaling 2 and put it in the top. 5 times 2 is 10, plus 6y equals 4. Subtract 10 from both sides to get 6y equals negative 6, and then divide by 6 to get a y coordinate of negative 1 for a final answer of 2, negative 1. It's important to make sure that you're actually writing your answers as ordered pairs, as the solution to a system is a point of intersection. Now at examples 5 and 6, you'll notice that everything is no longer stacked up, so I've got my equal sign stacked and my y stacked, but my x is on my wrong side of my equation. So I'm going to keep my top equation the same, 8x minus 4y equals negative 4, and on the bottom equation, I'm going to take this x term and bring it over, and to do that, I can subtract it from both sides. Now the other thing I want to do is I want to make sure I write it in xy order. So while this says 4y minus 3x, I'm going to rewrite that as negative 3x plus 4y, and then this will equal 14. And it's important, the 4y is positive, there's nothing in front, so that's why it's plus 4y, and the 3x is being subtracted, therefore it's negative. Now I'm ready to add these equations together because I now have a negative 4y and a positive 4y, which will cancel if I add. So pause the video at this point, complete example 5, and then complete example 6. Press play when you're ready to check your answers. So on example 5, I've got 8x plus negative 3x, which is 5x, and negative 4 plus 14, which is 10. Divide both sides by 5 to get x equals 2, and I put that back in the top equation. So 8 times 2 is 16, minus 4y equals negative 4, minus 16 from both sides to get negative 4y equals negative 20, and then divide both sides by negative 4 to get y equals 5 for a solution of 2, 5. On example 6, I'm going to keep the top equation the same, and then to line up the bottom equation, I would add 7x to both sides. When rewriting this in xy format, I would go 7x plus 3y equals 30, and then a negative 3y and a positive 3y I can eliminate by adding. 9x plus 7x is 16x, 18 plus 30 is 48, divide both sides by 16 to get x equals 3. I put this into the top equation. 9 times 3 is 27, minus 3y equals 18, minus 27 from both sides, negative 3y equals negative 9, divide both sides by negative 3 to get y equals 3, for a solution of 3, 3. So now we're going to progress to a system of equations where we can't just add or subtract, because for example 5 and 3, we either need matching coefficients or opposite coefficients. 5 and 3 don't match and they're not opposite, same with 2 and negative 4. But what I could do is, because I'm allowed to follow the golden rule, which is whatever I do to one side I can do to the other, I could multiply the top equation by 2, which would create a new equation of 10x plus 4y equals 32. My bottom equation I could keep as it is, 3x minus 4y equals 20, and now I'm able to add these two equations together to get my y terms to cancel. And so if I were to add them together, I would get 13x equals 52, because the y's have disappeared. Divide both sides by 13, and I would get x equals 4. Then I could take this x equals 4 and I could put it either into my original equation with the 5 coefficient, I could put it here, or I could even put it here. I'm just going to put it in the first equation I see. So I'm going to do 5 times 4 plus 2 times y equals 16. 20 plus 2y equals 16. Then I would subtract 20 from both sides to get 2y equals negative 4. And then if I divide both sides by 2, I'm going to get y equals negative 2. And again, my final answer has to be an ordered pair. In this case, it's 4, negative 2. This is kind of like adding fractions where you're looking for a common denominator. Here I'm looking for a common coefficient. And ideally, if I can get those coefficients to be opposites, that's going to allow me to add rather than subtract. So try examples 7 and 8, pause the video, press play when you're ready to check your answers. On example 7, I'm going to multiply the bottom equation by -3 to make the coefficient of x -6. Then I'll be able to add these equations together. I also needed to make sure I multiplied 3y by -3 to get -9y, and 5 by -3 to get -15y. Now I'm ready to add. 6 plus -6 eliminates. 5y plus -9y is -4y, and 19 plus -15 is 4. Divide both sides by -4 to get y equals -1. I took this value and I plugged it into the top equation, so 6x plus 5 times -1 is -5. I then added 5 to both sides to get 6x equals 24, and divide both sides by 6 to get x equals 4, so for a solution of 4, -1. On example 8, I multiplied the top equation by -2. Now I also could have multiplied the top equation by -11, but I liked -2 better because it's a smaller number. So this gave me -4x minus 2y and positive 18 on the other side of my equal sign. Because I have a -4x and a positive 4x, I can add these equations. -4x plus 4x is gone. -2y plus 11y is 9y, 18 plus 9 is 27. Divide both sides by 9 to get y equals 3. I plugged this into my original top equation. 2x plus 3 equals -9, minus 3 from both sides to get 2x equals -12, and then divide both sides by 2 to get x equals -6 for a solution of -6, 3. On example 9, it's a little different because there's no number that I can multiply just one equation by that would make my coefficients match. But if I think about fractions and think about having like fourths plus thirds where I need to find a common denominator, the common denominator of fourths and thirds would be 12, and fifths and seconds would be tenths. So I could either multiply the top equation by 3 and the bottom equation by 4 to get my x's to match, or I could multiply the top equation by 2 and the bottom equation by 5 to get my y's to match. It really doesn't matter, it's your choice. Whatever I do, I'm also going to do it so that way I can add when I'm done. So if I were to multiply, say, this by 3 to make it a 12x, I'd probably multiply this by -4 to make it a -12x. Since my y coefficients are already opposites in sign, I'm going to multiply the top equation by 2 while I multiply my bottom equation by 5. So my top equation is going to become 8x plus 10y equals 70. Don't forget to do it to every single piece. And my bottom equation is going to become 15x minus 10y equals 45. So now that I have a positive 10y and a negative 10y, I can add my equations together and my y terms will cancel. This is going to leave me with 23x equals 115. Then I'm going to divide both sides by 23. And 115 divided by 23 is 5. So now I have a bunch of places I could put that 5. I could put it here for x, or even here. I'm probably not going to use the two red and blue equations because they have bigger numbers. I'm just probably going to use the first equation I see. So I'm going to do 4 times 5 plus 5y equals 35, which is going to get me 20 plus 5y equals 35. I would then subtract 20 from both sides, which is going to get me 5y equals 15. And then lastly, I would divide both sides by 5 to get y equals 3. And so this means that my point of intersection is 5, 3. Pause the video, try example 10, press play when you're ready to check your answer. Don't forget on this one, not only do you have to rearrange first so everything is stacked up, you're probably going to have to multiply both equations to find the least common multiple. So I kept my top equation the same, 3x minus 7y equals 5, and to manipulate this one, I subtracted 5x over. Then I wrote it in the xy order, so negative 5x plus 9y equals 5. I multiplied the top equation by 5, knowing that this would make my coefficient of x 15, and multiplied the bottom equation by 3, knowing this would make my coefficient of x negative 15. I just had to make sure that when I multiplied by 5, I did it to every single piece, and when I multiplied by 3, I did it to every single piece. Then I added. 15 plus negative 15 cancel, negative 35 plus 45 became 10y, and 25 plus 15 became 40. Divided both sides by 10 to get a y coordinate of 4. I then replaced y in my very first equation with 4 to get 28. I added 28 to both sides to get 33, and then divided both sides by 3 to get 11. So my point of intersection would be 11, 4. Next, we're going to get into word problems. So this one is actually a recall from the robots, and so we're just going to make sure we're all good with how to set up this problem. So we're going to make orange and purple robots, and so it says we're going to let x represent the number of orange robots and y represent the number of purple robots. That should be enough. you want to make a total of 10 robots. So if you can picture having a pile of robots over here that's purple, and those we've called Y, and then having a pile of robots over here, which we've called X. Because I have a total of 10, that would mean that if I were to add the number of robots from the purple pile and the orange pile, that it would equal 10. Now when I write this, I'm just going to write it in XY order. It looks a little bit better. Next, it tells me that I want to make a certain amount of money. I want to have total sales of $7,000. Now every time I sell an orange robot, I know that it's going to cost $500. So every time I have one of those, it's $500. I don't know how many I have, but I'm calling that X. So if I were to have X of these guys at $500 each, that would give me 500X. And similarly for purple robots, they're $1,000 per robot, which would be $1,000 Y, and I want that to equal 7,000. So now I can use elimination to solve this system. And what I would do is I would multiply my top equation maybe by 500 to get it to match the bottom equation. Actually, I would probably multiply by negative 500. So that way, I would have negative 500x minus 500y equals negative 5,000. This will just allow me to add rather than have to subtract. And so now I can add my equations together. 500 plus negative 500 would be 0. 1,000 plus negative 500 would be 500y, and 7,000 plus negative 5,000 would be 2,000. Next, I'm going to divide both sides by 500, which is going to get me y equals, and don't forget I can cross off this and this, that would get me y equals 4. Now if I have a total of 10 robots and 4 of them are purple, that's of course going to leave 6 of them to be orange. And so this would mean I'm going to have 6 orange and 4 purple. And I could just double check the math, knowing that if there's 6 orange robots at $500 each, that would be $3,000, and 4 purple at $1,000 each, that would be $4,000, and $3,000 plus $4,000 is going to be $7,000. Try word problem 2 on your own. You want to start by writing a system of equations. Be sure to identify your variables as here they were given to you. Write a system, solve using elimination, and then explain using complete sentences what your solution means. So I started by letting X represent the number of earrings and Y representing the number of necklaces. I know that I want to sell 60 items. Now I don't know how many earrings I'm selling, but I'm selling 60 of them, and I don't know how many necklaces I'm selling, but I'm selling Y of them. But if I added all of the earrings to all of the necklaces, I know that I need that to equal 60 items. Now for the money, I know that every earring that I sell is worth $5 and every necklace that I sell is worth $10, and I want to make a total of $500. I'm not ready to eliminate since none of my coefficients match, so I multiplied my top equation by negative 5. This got me negative 5x minus 5y equals negative 300. Now by adding my system, negative 5x plus 5x canceled, negative 5y plus 5y became 5y, and negative 300 plus 500 became 200. When I solved for y, I got 40, so that means I would need to sell 40 necklaces. Now if I'm selling 60 items total, that would mean I'm selling 20 earrings. What this means in complete sentences is that in order to sell 60 items and make $500, I need to sell 20 earrings and 40 necklaces. And if you think about it, there's a whole bunch of different ways you could sell 60 items. You could sell no earrings and 60 necklaces, or 60 necklaces and no earrings. You could sell 30 of each. You could sell 10 of one and 50 of the other, or vice versa. You could do this over and over, listing all the different ways that you could sell all these items. But the only way for both of these events to occur simultaneously, which is to sell 60 items and make exactly $500, is to sell 20 earrings and 40 necklaces.